Hello students, in today's lecture we are going to continue with questions written on page number 103. We are going to try to see its solution and answers. Before we start with this, let me explain you certain important things. How to convert kilometer per hour into meter per second. You must have studied this in your lower classes also, but let us repeat it. See there, 1 kilometer per hour is equal to, instead of 1 kilometer, I will convert it into meters. So 1 kilometer is 1000 meters divided by 1 hour. I'll convert it into seconds, and 1 hour is 60 into 60, that is 3600 seconds. So 1 kilometer per hour is 1000 divided by 3600 meter per second, and after doing the simplification I can see the answer comes out to be 5 upon 18 meter per second. It means whenever I want to convert the speed or velocity in kilometer per hour, given in kilometer per hour, into meter per second, I have to multiply it by 5 by 80. This is one thing. I hope you know this already. So next thing, whenever you do any numerical, try to get the answer in 3 decimal places, and your final answer should be rounded off to 2 decimal places. For example, see here, I have written in short the important rules to round it off. Suppose if my last answer is 1.114, I want to round it off to 2 decimal places. Then I'll see my last number. This is 4. This is less than 5. If it is less than 5, then I'll keep this last digit same. It means when I want to round it off to 2 decimal places, because this last or next number is less than 5, I'll retain the same digit, same number. So the answer comes out to be 1.11, because I have retained 1, because the next number is less than 5. If the next number is which we are going to drop is more than 5, like here 1.116, or it can be 1.117 or 8 or 9. In that case, when I want to round it off to 2 decimal places, I will write it 1.12. I have increased this number by 1 because the next number which I am going to drop is more than 5. I hope this is clear to you. Now the question is, if the last this digit is 5, then what to do? Suppose if it is 1.115, then what to do? How to round it off? In this case, remember students, if the initial number, preceding number is odd, then we'll increase it by 1. For example, 1.115. This last which number we are going to drop is 5. So then, see that the next one, 1.11, it is odd. So what I'll do, I'll add 1 to this and round it off to 1.12. If the number before 5 is even, like here it is 2, 1.125, and I want to round it off to 2 decimal places, then I'll retain this even number. So this, after rounding off to 2 decimal places, it becomes 1.12. If it is odd, if the preceding number is odd, I'll add 1 to it. If it is even, I'll keep it same. I hope you have understood this simple rules to round off the number. Okay. Now let us start with page number 103, first question. Now the first question is not the numerical. I'll read it out and just listen to me carefully. When will you say a body is in 1. Uniform acceleration, 2. Non-uniform acceleration? Students, this we have already covered in one of the lectures. A body is said to be in uniform acceleration when its velocity changes by equal amounts in equal intervals of time. And we have taken the example of freely falling body for this. Okay. Second, when a body is said to be non-uniform acceleration, when velocity changes by unequal amounts in equal intervals of time, then the body is said to be in non-uniform acceleration. We can write here example, if we want to give, we can write a car moving on a highway and following the rules. It means whenever a car moving, you can say a car moving on a highway near a metro city. So you know there are traffic signals, and otherwise also when a car moves there is traffic. So it cannot be uniformly accelerated. Okay. Now next question number 2. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Whenever it is a numerical, you should read the question twice. Once I have read, now second time when I will read, we are supposed to write side by side what is given, what we have to find out. A bus decreases its speed from 80 km per hour to 60 km per hour. 80 km per hour is the initial speed. So I have denoted it by small letter u. U is equal to 80 km per hour. So speed is decreased from 80 km per hour to 60 km per hour in 5 seconds. It means initial speed, we know we use a letter u for initial speed, is 80 km per hour. Final speed v is 60 km per hour, and time, that is t, small t, is equal to 5 seconds. What we have to find? Find the acceleration of the bus. Acceleration symbol is A. So A is question mark. This we have to find. Before we start doing the numerical, we should see whether they are in proper units or not. Now these two are in kilometer per hour and this is in second. So let us convert u and v into meter per second. As I have explained you there, so convert 80 km per hour by multiplying it by 5 by 18 into meter per second simply here. And we can see the answer here comes out to be 200 upon 9 meter per second, and v is equal to 50 by 3 meter per second. No need to convert this into decimal places because this is just required for the numerical, but this is not our final answer. And this will be easier in fact. So now let us proceed. Formula for acceleration, we know by definition also, or we can use the first equation of motion. A is equal to v minus u upon t. So put the value of v 200 upon this, v is 50 upon 3 minus u is 200 upon 9 meter per second, and divided by time is 5 second. It is not necessary always we'll write the unit side by side. We can write it once and then there is no need. We can leave them. So here the LCM is 9. So we'll do the simplification. 3 into 3, 50 into 3, 150 minus 200 upon 9 divided by 5. And 150 minus 200 is minus 50 divided by 9. This whole divided by 5 means into 1 by 5. And after simplification, we see the answer is minus 10 upon 9. But we cannot leave it as it is because this is our final answer. It should be rounded off to 2 decimal places. So get the answer in 3 decimal places. Minus 1.111 meter per second square. As per the rules, round it off to 2 decimal places. And so the answer comes out to be A is equal to minus 1.11 meter per second square. I hope you have understood this numerical. Now third question is, a train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. A train starting from a railway station. Now given starting, it means u is, initial speed is 0 meter per second. And moving with uniform acceleration. So it is a case of uniformly accelerated motion. It means we can use the 3 equations of motion. It attains a speed of 40 km per hour. So final speed is 40 km per hour. In 10 minutes, time is 10 minutes. Find its acceleration. A is question mark. So because the train starts from rest, u is 0 meter per second. Final speed is 40 km per hour. Time taken is 10 minutes and acceleration we have to find. Next step is to see if any conversion is required. Yes, we'll convert this into meter per second and this into seconds. How we'll do? We'll multiply it by 5 by 18 and do the simplification. So this answer comes out to be 100 upon 9 meter per second. 40 kilometer per hour is 100 upon 9 meter per second. 10 minutes. We know 1 minute is 60 seconds. So 10 minutes is 600 seconds. Now again acceleration formula we can use by definition. A is v minus u upon t is equal to, put the value of v 100 upon 9 minus u is 0 divided by t is 600 is equal to, numerator becomes 100 upon 9 divided by 600 means into 1 upon 600. Zeros get cancelled, so we are left with 1 upon 54. And after simplification, the answer comes out to be 0.01851. Now here why I have taken more decimal places, I'll tell you why. Because once I have told you before also that whenever we write the final answer, normally we say it should be in, if a number is not very large, we say it should be having 2 decimal places. Take the answer to 3 decimal places, round it off to 2 decimal places. But if the number is very large, okay, if it is having large number of digits, or if the number is very small, then we prefer to choose this method. I have already told you before also how we'll do. We'll write first this number less than 10. It should be more than 0, less than 10. And here if I choose 18, it will be more than 10. If I choose this 1.8, that is better. It should be, not more than 0, we can say it should lie between 1 and less than 10. Okay. So this first number should be more than or equal to 1 and less than 10. So here I have 1.851 is the best choice. 1.851. But if I write it 1.851, then I have to multiply it by, since I have shifted point by 2 places towards the right hand side, so I'll write 1.851 into 10 raised to minus 2, because shifting of decimal point is by 2 places towards the right. I have not written 1 here because I have directly rounded off to 2 decimal places. So the final answer is written in scientific notation as this. The first number should be more than 1 or equal to 1 or more than 1 and less than 10, not 0, remember that, okay, into 10 raised to, if it is number is very small, it will be having negative power. If the number is very large, it will be having positive power. Hope you have understood the semantic. And now let us do the questions given on page number 107 of the textbook. First question is, what is the nature of the distance time graph for uniform and non-uniform motion of an object? We know that when a body is in uniform motion, it covers equal distances in equal intervals of time. And whenever one quantity changes or is covered by equal amounts in equal intervals of other thing, then the graph of one versus the other is always a straight line inclined to the two axes. And if you remember, ST graph for a body in uniform motion is a straight line inclined to time axis. Here equal distances are covered in equal intervals of time. For non-uniform motion, what is the nature of the distance time graph? I have first drawn the ST graph for uniformly accelerated motion, and it is a kind of non-uniform motion only. And next I have drawn again one ST graph where the line graph is not a straight line. It is a combination of 2 straight lines. Means a body remains in uniform motion for some times initially, but again it remains in uniform motion, but see the bend is changed, the slope is changed. It means again the speed is changing. So these both are graphs for non-uniform motion. Overall we can write the nature of the distance time graph for non-uniform motion is not a straight line. It can be a curve. Okay. This is, I hope, clear to you. Now come the next question. Second question is, what can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Now, students, if distance time graph is a straight line parallel to time axis as I have drawn here, to be more perfect, we should remember that it can be a position time graph. Or if we consider distance time also, we can assume that the body is already some distance away from origin and the distance, see here, is parallel, this graph is parallel to time axis, means as time passes, this distance is not changing. So distance of the object from the origin remains constant, it is not changing. That is the case when the body is at rest. So here our answer will be the body is at rest or it is stationary. Now the third question is, what can you say about the motion of an object if its speed time graph is a straight line parallel to time axis? Now here, if speed time graph is a straight line parallel to time axis, let us imagine or draw the graph here. This is speed, time, straight line parallel to time axis is this. So if the graph is this way, what will you say about the motion? Now in this case, students, we can see that as time passes, the value of speed remains constant. It is not increasing or decreasing. So speed remains constant, and we know when speed remains constant, the motion is uniform motion. So what we'll say about the motion of this body whose speed time graph is a straight line parallel to time axis? The body is in uniform motion as speed remains constant with time. Now the last question of this page is, what is the quantity which is measured by the area occupied below the velocity time graph? Quantity measured by the area below the velocity time graph. Okay, we can have a look at this graph only. So we can take this area. If we shade it, if I drop a perpendicular and shade this area, you remember what is the quantity measured? Quantity measured will be magnitude of displacement covered. See, this will be a rectangle and length into breadth will be V into T. We know V is S upon T. So S will be equal to V into T. So quantity measured by the area occupied below the velocity time graph is magnitude of displacement covered. If it was speed time graph, we can write distance covered. This we have done before also under the uses of graph lecture. I hope the questions that we have done today are clear to you and will continue in the next lecture. Thank you, students.